What's the electrical tape for? Okay. Okay. Well, we'll start. I kind of get volunteered. I have to have a little more resistance. My name's Eric Wyatt, right? Blue Starr Oyster Company and with OceansAlaska. That is an organization. We're based out of Ketchikan. Tommy Marsh, who's sitting right over here, raise your hand, is our president of OceansAlaska. And so I'm going to talk about that at the beginning and then my own business later on. So we have a floating hatchery facility. And kind of related to Brianna's presentation, one of the things that we're doing right now is leasing a facility during, a good half of the year to Seagrove, who is running, a major kelp nursery there. And then there was an off time, right, starting around in January for about 5 months or so. And so what we did is stood up, moving all that kelp hatchery stuff out and turning it into a shellfish hatchery. So first off, here we're saying there's some credits there because our shellfish hatchery program, right, was in partnership with AFDF, with a Saltonstall Kennedy funding. And now we're going to continue that, hopefully for the next couple of years, with the USDA funding. And so what you're seeing right here, this is Saxman Harbor, which is, Ketchikan is right there, and it's looking kind of toward the north and west. Okay. Here are our overarching goals of our organization. I don't know if you can, of this program, I don't know if you can read that, but one of the things that this kind of relates to Brianna's presentation too, and that's like we're into promoting, leveraging, utilizing existing facilities. So that's kind of by having this kelp hatchery, right, nursery, and now we're doing this in the off season. From that, running the shelf, I'll get better here in a minute. The oyster hatchery portion. I don't know anybody else that's doing that. So that's this time element, right? And it makes sense. So not only are we're figuring out how to spawn and set oyster seed, and I'm going to show you using some new techniques, right? And what we did is we had a lot of help with the actual hands-on from an expert. Many of you heard of Proven Crump, who lives in Prince Rupert, right next door to Ketchikan. So we're doing the physical part of having an actual hatchery and then having, I would say, non-traditional, meaning hands-on training. You come and learn how to do this. For interns or workshop, we've had various links, and we're adaptable, and we're going to be running this again in the future. Adaptable meaning it's not just a set program necessarily. We can modify that a bit. Right, we're expanding the technical capability. In my opinion, we haven't been very successful in Alaska in spawning our own oysters and having our own ability to supply some meaningful amount of our seed. And we need to do that in terms of, from our own security point of view. And one of the reasons I even got into the seed thing as a farmer was because I couldn't get seed back when there was, a few years ago, having a lot of issues down south. And as we go into the future, having some component and ability to provide our own is security for our industry. And it's also, though, this great training venue. Kind of as Dana was talking about, you get people that learn the science part, and a good number of those people become part of the industry too. So, and additionally, even just introducing, say, young people, we have high school students, et cetera, to science helps open up this other door of possibility for the future for them. And even that, I think, is positive to do. So Right, that's part, like educational tours. What level of hands-on are we doing? So, down here I got a couple words. I was trying to remind myself, I like to read, I guess, agricultural, like now it's regenerative agricultural magazines for years. Think of myself as a farmer, but I'm a third-generation fisherman, but getting into oyster farming had to start thinking differently. Yeah, and not a hunter-gatherer anymore. You know, there's a longer-term commitment to this crop. And so I just read this recently. A farmer was talking about, and this has to do with your crew, with trying to recruit new people to work with you. You might, as an individual or company, have the capital, have the know-how. We need the people to do it, right? Or it's, as usual, just me doing something, you know, or one of my kids. And so key to that, though, is the idea that you got to give people, I mean, in this business, in this endeavor, a sense of purpose. So for me, I know mariculture is this positive thing. I think I'm doing something that is generally good for the environment in my community. I don't see it as a negative in the big picture. So, I mean, I could be doing something else, but that's what that I wouldn't think was being good for our community and the earth. But it's a little smushy on that idea, but that's the purpose anyway. Autonomy, and that's something I have to learn too. You can't just be breathing down someone's neck all the time. You get them some level of skills and let them learn to do it. And then mastery, and I see that when there's a way to get better. It's not just one job where you're doing something. There's all these things that we can do, including in the hatchery. There's high skill level that can be achieved if you want to. Okay. Sarah is here, helped me put this together. So this is last year. This is pictures from last year. This is in the algae room on the barge. And so you can see these are the algae starts and kind of have a little library. I mean, you know, there's a repository that I think NOAA has, right, that you can even order them from. And here, these 2-liter flasks are the biggest that we grow them to. Now, in the past at Oceans, I know they would grow to like, you know, 2.5-liter, or these big carboys, and then they'd be moving those later to start your production. So this is one of the things that Proven helped introduce us to is, and I saw this in the past without, you know, learning about hatchery stuff, is we have some small people working in the hatchery, and you could not be carrying around these big flasks of stuff and climbing up on ladders to inoculate big tanks, and we need a different method, and that's actually now kind of the cutting edge of microalgae production. And what we're doing here, though, also is advertising this year. This is 2023. So if you have some interest in doing an internship workshop in Ketchikan, then I'll have contact information in a minute. So I'm not sure if you can see this thing. One of the things that we did with the, you know, because of the funding from SK, is we bought a thing called here we go. Well, PBR is a photobioreactor. And we'll see in a minute more, but of a system that helps, I won't say automate, but a bit, automate and monitor the microalgae production. So what we're growing here is, you know, oyster food, right? Microalgae. And it may or may not be something that's necessarily grown out here in the ocean. Those strains are things that they found that would grow in a hatchery and you could grow well, all right? Carrots don't grow out in the wild here, but we eat them, you know. So it's something like that we're growing. Strains that work. And that's my time? Oh, okay. Not 6 minutes left. Oh, shoot. Okay. We'll hurry on. One of the things is I'm trying to point out, we had 2-liter, just these small algae, you know, inoculation. And here's a 25-liter bag that's right down next to the other system. So you actually just take some hoses and, yeah, pump it over and start. You don't have to carry these things around. I said photobioreactor. There's a couple different, you hear this kind of term, and there's a couple different available commercially that you can buy. This is one of the systems. And here is a 250 liter, so right across from it, just a few feet away, was that smaller one, and they run hoses over. You can, and there's a bag in there, and what this little computer, I think it's a Kindle actually, but it, you know, we can control the pH by, controlling the amount of carbon dioxide you're pumping in there, and you can also have an app on your phone when you're not even in the hatchery. You can see what the temperature is, the lights are on, what's going on. And so running, what we did was have several times better production out of one of these than our traditional KW tubes. And I'm not sure if you can see in here, but those were our traditional tubes, but we set them up in a different way to continuous production. It's hard to describe, but each step of these things, I think our production of algae was, for the size, 10 times better than we had ever in the past, and much easier. So it's hard to figure out the economics, but if you can afford these types of systems, there's a lot of benefits. So we'll go on. One of the things we did some strip spawning, actually did spawn. Those particular ones we didn't make it through to the nursery, but we also did some remote setting with larvae from Bryan, Hawaiian, to go through the whole process. So this is talking about the workshop program. Okay, there's my email, and if you're interested in doing it, there's some pictures from last year. All right. We did talk about what would be a dream hatchery in Alaska. Small footprint, high output. What would be the characteristics? And this is from last year's ASCA conference, and we are working on almost all of those things so that we can fully understand and get these lessons learned for the future in Alaska. Okay, so I've got a farm and a big nursery system. Here's a Flupsy, right? This thing's like 53 foot long. These bins right here are 2 by 2 foot. Screen bottom, I got 126 of them. You can see it's a paddle wheel driven, off the grid right now. Eventually I'll be on hydropower electricity, so there's a screening system we use over here on the left. This is a tour. And you can see, because these bins are smaller, I have a pretty small hoist system. So I looked at systems elsewhere down south, and we came up with our own version. Okay. It's a catamaran, so in the winter, I want to defoul it. We pump those big pontoons out. The whole thing comes up out of the water. So about 6 inches of the pontoons are in. Can defoul, clean the whole thing. And in the past, I could actually take this, and change the zincs and do stuff like that. Okay. This is the seed size, 5/8 screen, that I've really been moving towards. It cuts down on the total amount that it can produce, but this is like, John, that's what I sent to you out there, especially I think in Prince William Sound and out, where it seems to be colder waters and the Cook Inlet, Katchmack there. I think this big seed really makes a difference. And it's about, I think, twice as big than I used to get when I was starting. Will the video play? So what I wanted to show here, one of the other aspects of this Flupsy, is those bins there have outflow screens. I hadn't seen that anywhere else. So example, a bin that's got 4 millimeter stainless mesh on the bottom, we have an outflow screen. It's also 4 millimeter. And what we are doing is we're able to work the seed right in the water. And what this is showing is I have like a Honda trash pump, right? 1.5 inch hose. So we're driving a big amount of water down, but it's actually taking air and driving, as it comes down, we're holding it up, it's driving air all the way down. And well, it's not quite showing, but the seed is just roiling here, all out. So either we're physically screening it that week or we're working it. And that helps give a good shape, right? More uniform growth in that bin. There's a number of benefits. So that's good. Oh no. Okay, one last little bit. Time's up. Oh boy. One of the parts, so this was also some SK funded. We got, oh no, seed. And what I want to say is this. Here we go. What this is saying, Brian, is we did test diploids and triploids together. And we have some farm partners where we tested some samples too. And I would say the results are mixed, about difference. Diploids don't grow a whole lot faster. But one other thing is, what I'm saying here is that if I got the seed like at 3 millimeters, a size versus 2380, I got almost twice as much out to market size that year, right in that spring in 5 months. So, questions? This is the temperature graph. Last year was a little bit warmer than the year before, so maybe that helped boost that. Those numbers on the size made a big difference, but probably not a tremendous amount. Here, it did get warmer, but meaning 2022, right here in August, right, you can see a bump there. That really helps the seed. But every year is different. It's not just going up like a rocket. Okay, we're at the question time, or is that up to? We're out of time. We're out of time. Stuart? Hey, I'm making you look good already. Come on.
Thank you. Hello, everybody. My name's Stuart Thomas. Waiting to get my talk up here. I just wanted to thank you very much for the opportunity to speak here. Weatherly invited me. I'm really excited to share some of the work I did. I went to graduate school in Alaska, and I worked on a breeding program study, comparing some broodlines of oysters between Alaska and Washington. And we looked at a number of different parameters. It was funded by Sea Grant. We had help from the Alaskan Broodstock Program. The USDA also was involved in the funding, and obviously support from the University of Alaska, where I did my master's degree and did this thesis work. So, and I want to give a little bit of a perspective after that on some broodstock management, which is where my career took me after that. The question is, what can I tell a bunch of Alaskans about Pacific oyster breeding and quality that they don't already know? This is an intimidating group. The Alaskans are a bunch of badasses. I'd like to tell you a little about myself. You don't know anything about that. That's good. So we did a breeding program assessment, and we assessed growth and quality between these molluscan broodstock program broodlines between Alaska and Washington. MBP, that's the molluscan broodstock program. I'll talk a little bit about some prior studies. I might gloss over that in Alaska. But we looked at, do biometrics and performance justify a specific Alaskan breeding program? We did a little biochemical assessment of quality and how can Alaska leverage these unique traits of their Alaskan oysters? And talk a little bit about the implication and timing of reproductive condition we looked at Alaskan oysters. And then I'll talk a little bit about some perspective I've gained since in a career in broodstock management. Oh yeah, sorry. Thank you. That's better actually. That way I can see the screen. So with broodstock management, is timing everything? Location is very important. Is simpler better? As farmers, you really know what you're looking at. You're there day to day. You're looking at your product. Encouraging collaboration between academia and farming. It's really important to ensure success. And that quality is key across the board. And I'll talk a little bit about some of the breeding programs that are out there. A little bit about me. I'm here to talk about Alaskan oysters. I got a marine biology degree in the UK. I did my master's here. I was based at the Fish Tech Center in Kodiak, where I did the research that I'm going to talk about. And then since then, I spent 7 years as a broodstock manager at Taylor Shellfish Farms in Washington State. And then to date, the last 5 years, I started in running an oyster farm and company for the Swinomish Indian tribal community on Fidalgo Island in Washington. And on the side, my wife and I it's her business, we operate a pop-up oyster bar, Seize the Day Traveling Oyster Bar. And we sell and serve the oysters that grow at Swinomish Shellfish Company. This is just a hodgepodge of pictures from Swinomish Shellfish Company. I think I'm just going to move past this a little bit and move on to the work that I did. You might notice that the dates are kind of a long time ago. So I'm a little embarrassed to be here now just talking about it. And it was a bit of a challenge for me to think, well, how do I tell this story and make this relevant now? But there are some key take-homes in here that I think could be useful for Alaskan oyster producers and also for Alaskan oyster breeding. So a brief overview of the study. We looked at 2 sites, one down in Washington State in the Hood Canal, Thorndike Bay. Actually, Joth Davis, who spoke earlier, hosted the study on his farm. Thank you, Joth. And then the second site up here in Alaska was in Kachemak Bay in Homer. I'm sure many of you are familiar. And Greg and Weatherly Bates were taking care of all the oysters there, so big thanks to them. We had 2 sampling times, one in the fall, one in the early summer. And we narrowed down from 45 broodlines from this breeding program to 7 broodlines that were selected for their best performance in Alaska and compared those to the Washington oysters, the same broodlines, the same families. And we assessed the physical, biochemical, and reproductive condition of those oysters. Quickly, just looking over at this pedigree chart, it may be hard to read, but the cohort we worked with was 20, was put out in 2006. This came from several generations prior, and the oysters that contributed to these previous generations were from Oregon, from California, from Washington, and also from Alaska. So there's some Alaska genetics potentially in there from Prince William Sound. So you can see that there. And as I said, there was 45 families initially planted, and we took the top 7 performers from Alaska. And immediately, something that became evident was that when looking at the Alaska families, oh shoot, what did I do? It's gone away. Press the middle button. Should I press it again? Oh, there it is, good, okay. What this graph is showing is, we based that in terms of survival. It was the easiest metric to determine who was successful quickly. But quickly, what this shows is that the order of families and their success surviving in Washington, in Alaska were different to that in Washington. And what that is telling us is, in fact, that those families that are successful in one location are not necessarily those families that are successful in another location, and that in itself would be justification for an Alaska-based breeding program, creating your own Alaska-specific broodlines. This graph makes me look super smart. Don't ask me how I made this, it was 10 years ago, but I can tell you what it means, and it's backing up what I'm saying. Essentially, if an oyster was successful in both environments, you'd find them in these upper right quadrants. And these are for overall yield, overall growth, and survival. And you can see that only in terms of growth, which is important, do they find themselves in the top right quadrant. And this sort of lack of relationship, or this jumbling, or this is not showing that relationship, is showing again that oysters doing well in Washington are not the same families that might do well in Alaska, and again, sort of backing up that need for a tailored Alaska broodstock program. So what did we look at in depth? The initial field analysis, we took those top 7 survivors, and that set up the project, and then we went back and sampled again after those had grown out for a period of time. We sampled in early fall in October, and then again in June. And so the idea was that they'd see at the end of the summer after they've been feeding and having the best conditions, and then after that challenging period of the winter. And we would look at the differences and how these oysters were performing. And I'm not going to drill down too much on the family differences. I really just want to focus on the information that came out from the quality parameters of the Alaskan oysters, because I think these are the things we can focus off and that we can take from this study, especially since it was so long ago. We looked at the environmental conditions at both locations. The environmental data wasn't great, but it was still useful. And then we looked at oyster survival, biometrics, and some shell shape condition indices, and these are metrics that encompass whole weight, shell cavity, and meat content, and they can give you a nice round number that you can use to compare. And then we drilled down pretty hard on the biochemistry, and we looked at proximate composition, which is essentially the whole of protein, glycogen, and lipids in the leftovers, and telling you how much of each of those is present in that oyster, or those oysters. And then we did a lipid analysis too, so we drilled down on the fatty acid composition of the oysters in the sample. And this is actually really interesting, and I think there's some really great data coming out both of those parts that can be used by the Alaskan oyster industry to help market and promote and differentiate your product. And then finally, we looked at the reproductive condition of the oysters and using some simple techniques. And oysters don't reproduce here, but they do develop reproductively, and there's some cool take-homes from that that can be capitalized upon for Alaska. So quickly looking at the environmental data again, black was Kachemak Bay, gray was Washington. Guess what? Alaska's colder. But there's a couple of key thresholds that are important for oyster physiology. First is that between below 10 degrees Celsius and down to 3 degrees Celsius, feeding is inhibited in oysters. That's important to remember. And below 3 degrees, they don't feed at all, which, as you can see at times in Kachemak Bay, that was happening. And above 10.5 degrees Celsius, that's when reproductive development starts in Pacific oysters. Just note that I'm talking about Pacific oysters the whole time in this talk. And oysters won't spawn until they reach temperatures above 20 degrees Celsius. Again, that's something you don't really reach very often in Alaska. So these are just some important numbers to look at in the environmental data, which wasn't that great or that helpful for us in the end. So we looked at the oyster survival, the biometrics, and the shell shapes. The data showed us through differing performance of MVP families that there is a justification for an Alaska-based breeding program, as I mentioned in some of that prior data. And that survival and consistency are our most important parameters. Some people already mentioned that earlier, both for breeding programs to focus upon, but that's what the farmers want too, right? Because you need that consistency, but most importantly, you need live oysters to sell. And I will say, from my opinion, is husbandry practices, farming practices, are equally important to breeding and performance selection. And much of the selection for these golden ratios, this width to length, 2 to 3, and these deep cups, has actually been taking place already. And a lot of the brood stock that's out there already is already pretty high quality, and you should be seeing this quality in your seed that you're receiving from these producers. But also that farmers can just see these outcomes without all the experimentation and data collection and work of breeding programs. It's expressed daily. You can see it. You can see the best oysters. You can see the best shaped ones. Is the fastest growing oyster the best oyster? There's a debate between generalists and specialists, and this is stuff that you'll need to work on in Alaska to determine the real answers that work for you. And we looked at shell thickness, and noting that resilience and adaptability, ability to adapt to education, is also key to good end product. Drilling down a little bit on the biochemical composition, we used that to determine quality. And intrinsic quality is defined by the parameters I talked about, biologically, but also as a product. What are you selling? And when you're looking at these quality parameters, how can you use those to market your product, promote your product? And so how did they differ? Again, I'm not really looking at the data itself. It was a long time ago. I'm not sure how relevant it is now. But these patterns will hold true now still. So the Alaska oysters, and I'm also not comparing too much to the Washington oysters. I don't want to focus on that. The Alaska oysters had significantly more glycogen, and they had different distributions of fatty acids to the Washington oysters. They were higher in omega-3s and omega-6s, and they were higher in DPA and EPA, which are, these are fatty acids that we can't make ourselves in our own body, and that you need to consume. And funnily enough, so the oysters can't either. They're getting those from the diatoms and the phytoplankton that they're eating as filter feeders. And so that was some of the findings there. And interestingly also, although perhaps less relevant to your production, there was significantly less protein in Washington than the Washington counterparts in the Alaskan oysters after overwintering. So basically they were starving because there was so much less productivity here in the winter and it's cold. But interestingly, during that period, they had proportionally more glycogen present, which they're storing for a reason. I'll go into that a little bit too. Reproductive condition. Alaska is cold. Reproductive development of Pacific oysters only occurs above 10 degrees centigrade, 10.5. And in Alaskan oysters, the gametogenesis, the creation of these sex cells, the eggs and the sperm, is significantly slower than at lower latitudes, and spawning will not occur below 20 degrees, as I mentioned. However, the foundation provided by Alaskan water quality that's building up all of these awesome resources is prime for developing healthy and high-quality broodstock. They need those resources to be in the best condition to breed. And because they don't reproduce, they kind of keep hold of those all the way through the summer here. I'm not going to talk about degree gauge too much. But yes, timing of peak reproductive development can be simply assessed, and we did do that in our study, and this is something you could do here too. It's really easy. You just sample the oysters, you cut a cross-section, you preserve them in formaldehyde, and then you can get free imaging software online, and you're basically just looking at the proportion of gamete or sex cells, eggs and sperm, to the rest of the body. And I think it would be a really cool study to do. We only did these 2 time periods in the late summer, and oh man, I'm running out of time. Anyway, it'd be really cool to do a month-on-month thing here, and it would be very easy to do, and please come talk to me if you'd like to do that too, because if you're going to start hatchery production here, you're going to want your oysters to be in the best condition possible. It was interesting that most of the oysters in Alaska were found to be in good or excellent condition. That's really awesome. And these indicators can be, these condition indices can be an indicator of reproductive progress and potential for success in the hatchery environment. Yeah, so why are these differences useful? I'll just wrap it up as quick as I can here. What is glycogen? Glycogen is basically carbohydrate, sugar. This imparts a sweet taste. So Alaskan oysters have more sugars. They're very sweet. People who've eaten them can probably attest to that. What are the fatty acids, or why are the fatty acids important? They're key components in cell function, and Alaskan waters being cold have higher levels of those fatty acids so that cells can function more effectively. And these have been shown to have positive cardiovascular and neurological benefits, and they also impart a smooth mouthfeel. It's a good quality experience. What is the protein? Oysters are mostly protein. Alaskan oysters are low in fat, high in healthy fats, high in protein. So Alaskan oysters are superfood. Alaska oysters are a mega superfood. Alaska oysters are in good and excellent conditions during certain time periods. And I know you guys can only really harvest in the summer months, I believe, at most places. Maybe that's not true in Southeast. And what are the benefits of reproductive development without reaching peak spawning condition? Well, spawny oysters are not palatable, so you never reach that peak spawny phase here. That's great. And partially developed reproductive resources are excellent broodstock source. So you're getting all the right resources in place in Alaskan oysters, and then you can take them to the hatcheries, and they should perform really well because they really got good backing there. And the final thing we didn't talk about, but the uncharacterized quality that you guys can have is that you have pristine glacial-fed cold water oysters here, and that is really amazing. So Alaskan oysters, in summary, are just awesome. Yeah, and this information should be worked into marketing and promo language to differentiate your Alaskan oysters. I won't talk too much about that since I'm running out of time. And if anyone wants to talk to me about my broodstock management experience, please come to me. I had 7 years of it, and hopefully I could provide something useful. So here are some of the partners that are working that you might want to work with to develop these breeding programs. And of course, OceansAlaska I didn't include in this list, but they were obviously a key partner too. So I'll wrap it up since I've run out of time. And here's just a big thanks to all these people, and I'll take any questions if there's time now, too.
sales points in there too. I love it.
Oh, can I say one more thing?
Yes.
This was funded by Sea Grant, and the data in this study is available for you to use. So please approach me if you want the actual data itself. This was made to promote, Alaskan oysters.
Thank you. Dave, welcome. Dave Bailey, Woods Hole.
All right, hi, I'm Dave Bailey from the Woods Hole Oceanographic Institution. Here to talk about our selective breeding program that's been going on since 2018, and this is for sugar kelp. And I'm not going to go over all the details of everything, just a quick 5-minute why I think this is important for Alaska to start using some of this technology and techniques. And I won't go into the genetics because Joth covered those really well in his oyster presentation there. But we're using selective breeding unlike the hybrid breeding that they're doing. So we're going out in the wild. We collect seaweed from all these different sources up the coastline where it's found. And we're selecting parents, and we're just randomly crossing these parents. And then we're looking at the offspring and trying to figure out how these phenotypes, so how these characteristics are moving from one generation to the other, and if we can actually select for them. And this all was funded by the Department of Energy. So they want to figure out how to grow seaweed for biofuel. So the most important phenotype for us was yield. So we're looking at weight per foot or weight per meter. But we also think that this has industry applications for processors and other people because we can select for other stuff we realize. We can select for stipe size, blade length, blade thickness, sugar content. There are all these different characteristics of the seaweed that we can actually select for. And so we are doing this on the East Coast with sugar kelp, and then there's a team at USC that's doing this with giant kelp. So this is the life cycle of sugar kelp and brown kelp in general, really. We have the source tissue, and we have the myospores, and usually that's what's put on the spools. So we saw the seed spools that were seeded before. We don't do that. We move to this next generation called the gametopyte stage. And so at this gametophyte stage, you have males and females. And what we do is separate those, and we grow those in cultures. Like Eric was talking about with the phytoplankton, we grow it pretty much the same way. So it's the same techniques that are already used in oyster hatcheries can be used to grow up these vegetative cultures. And then we just take random males, random females, and combine them together and sort of see what we get. And I think this is really important, especially for more threatened species. So if we're talking stuff that may be of concern, maybe bull kelp or something like that, we can reduce pressure on the wild populations by not actually going to those wild populations year after year and collecting source tissue. We can have a bank of these, so we don't need to keep going back to the wild. And we can also control timing. So this is a big thing when you're outplanting. There's an optimal window for each farm when to outplant, and we always want to hit that window, but it always seems like there's something wrong with hatchery or we couldn't find source tissue this year, and we never really hit those windows. And so by using this method, we know exactly when we can outplant, we know when we need to start everything in the hatchery, and we can also have multiple spawning runs using this. And so this is the East Coast. I'm sorry, the bigger map doesn't even show Alaska here. Usually we're talking to people in Europe and stuff. But this is up in Maine all the way down to Long Island Sound where we collected our kelp. And so we did a population biology study first to make sure that we could actually move kelp from Maine down to Long Island Sound and vice versa. What we found is we really can't do that, actually. There are two different populations. So we have the Gulf of Maine population and then the southern New England population. And so we put these boxes around here because these represent the 50 kilometers in Alaska that you have to use for your broodstock. And so if we go to this next slide, each box sort of represents those zones, and you can see the different morphology within each one. So we're using all these characteristics that are naturally found in the populations and sort of accentuating them year after year. And so every year for the past 4 years, we've been planting at a farm in New Hampshire, and we plant these meteor plots, and each plot is a different cross. And you can see that we get quite a variety. We get some with very skinny blades. So this is the skinny kelp, which is a really good product for the processing industry. We have wide kelp, we have short kelp, and they all have different nutrient profiles and everything like that. And so we're trying to figure out how we can accentuate these traits and really get a product that's consistent year after year. And they were talking about oysters having consistent growth year after year. Because of the farm, we can't control the farm like we could control a field. We're not adding nutrients, we're not adding water and stuff like that. So there's all this natural variability. And if we can find cultivars or crosses that year in, year out produce the same yields, it'll just help with production. And so the last thing that we're doing is trying to figure out how to use sterile kelp. So there's a big thing with like selective breeding. If we're doing all this selective breeding, what happens if we have like crossbreeding with wild populations and stuff like that? So one way we think that we could sort of reduce that risk is by having sterile kelp. And so we're using the same sort of process we're using for our breeding program, which is this like genome-wide sequencing, where you can actually find sterile kelp in natural populations and just propagate those sterile individuals. And so we're in, I think, the second year of doing this, and I guess I can say we have potential sterile things. We haven't found official sterile kelp. You have ones that don't produce source on the farm. We have ones that produce like spores that aren't motile. And we really need to figure out like year after year if we can actually produce these sort of sterile individuals. And I know that was quick, but that's what we're doing. And if you guys have questions, let me know.
Thank you. So now we've built in some time for tabletop discussions. We're a little bit over time, but let's go ahead and take the next 15 minutes and either stay at your table or make your way to another table. We provided some guiding questions for these different sessions. You can read them or not. It was kind of up to you to spur conversation. But what we're interested in doing is capturing the top innovations, concerns, or issues that your table comes up with. So we're going to ask that someone is the scribe for the table and just captures those highlights. We have a couple of folks that are volunteering that may come sit at your table or talk amongst your new friends at your table and decide who's going to do that. So as you discuss this, focus on hatcheries, nurseries for now. If you move on past that, that's of course fine, but let us know what those top concerns, issues, or innovations are that you discuss. And then right after that, we'll go to a break. All right. Thank you.